Two-stroke, another advantage, I have more power to weight. I don't have a valve train. I don't have an oil pump. I don't have an oil reservoir. I don't have any cooling system other than just the flywheel that blows air. That's my cooling system. I have all this less stuff, which means less friction, less energy loss, and so less weight to have to move. I have a lot more power to weight ratio. I have less moving parts. When you look at a string trimmer or a chainsaw, basically I have a piston, a connecting rod, a crankshaft, and a flywheel on the end. And the only really moving parts is the piston and the connecting rod, and that's it. It can operate in any position. I can take a chainsaw, I can flip it up inside down and right side up. Because it has no oil in it, it doesn't matter. If I flip it upside down, the oil doesn't run into the piston because it's in the air. It's cheaper to buy because there's less parts. It's easier to manufacture. There's less resistance. There's no oil for the crankshaft to have to churn up. And so there's all those less components to be turning. I have less friction. It's going to actually operate more freely and more efficiently. I got to make sure that I mix the fuel. There's some two-strokes out there that you put oil in one reservoir and gas in another, and it injects the oil and mixes it, but most of what you're going to deal with, you mix it into the gas. And so 50 to 1 would be 50 parts gas, 1 part oil. 32 to 1, 32 parts oil or gas, 1 part oil. We talked about that already. Make sure you mix it, and you want to mix it according to the little container. And so, and read the manual, because some manuals are going to be different, but usually it's the oil that's going to determine how well you can mix it. I'm going to kind of skip over this, but the difference here, valve arrangement, you've got overhead valves and you have in-head valves. Looking at these two engines right here, both of these engines are 8-horse engines. This one has a tin cover out here. It's got overhead valves. This one here has a flat head. The valves are down in the side of the block. The big difference is going to be how much compression these things have. This is a high compression engine. This is a low compression engine. This one's going to run less efficient than an overhead. Anything with overhead valves is going to have a more efficient, it'll be a better quality engine than an L-head valve or an L-head engine. And so when I'm going and I'm going to buy an engine, is it overhead valves? Does it have pressure lubrication? Does it have an oil pump? What does it have? Overhead valve is going to give me more compression ratio, higher, and it's going to have less emissions. Looking at compression pressures, in a gasoline engine, a typical compression, if I'm going to take a compression test to see what the condition of my engine is, typical numbers I'm going to see is from 60 to 160. If I take a compression test on an engine and it has less than 60 pounds of compression, its likelihood of starting is pretty much 0. That engine has a problem. It needs to be taken in for repair. If I have an over 160 pounds of compression, what's going to happen is when that piston comes up, it's going to compress the mixture too much. It's going to cause too much heat. And since the air and the fuel is already in there and it's mixed up, if I put heat with air and fuel, I get ignition. And that's where you get that detonation that we talked about on the test and then earlier in this quarter. And so detonation would come if my compression ratio was too high. And so we're limited by that. Diesel engines, they start around 120, less than 120 they don't start, and they go all the way up to 500 pounds of compression. So you put a compression test in there and crank that engine over, 500 is a very common number to see. That's a high compression diesel engine. What is compression ratio? Compression ratio is the volume above the piston between top dead center and bottom dead center. That's what those two initials stand for. It's expressed as the ratio. A gas engine is an 8 to 1, which means I take 8 parts of an engine, 8 parts volume, and put it into 1, or 14 to 1. That's the maximum compression I can have on a gasoline engine before I'm going to start seeing detonation, or I'm going to have to start using special fuel. I'd have to use premium unleaded fuel if I start running up around 14. If I tried to use a 15 to 1 compression, I'd have to run premium unleaded fuel to deal with the detonation and problems that I'm going to have. And so that's why you don't see them get higher than that. On a diesel engine, we're not going to start until we get to 16 to 1. And we're going to go as high as 23 parts to 1. And when you mix that much volume into one small area, you're going to create a tremendous amount of heat. And it's that heat that we're creating that we're going to use to ignite the fuel when we actually throw the fuel in there.